Yes. Good morning, dear students. So, I welcome you all for today's video presentation. So, today we're going to discuss about some hydraulic system devices. So in previous class we discussed about the various types of hydraulic fluids, properties of the hydraulic fluids, and the functions of the hydraulic fluid. So, in similar way, so one more important component is that is hydraulic seal. It is a device or it is a component that may be used in the hydraulic system. Okay, so a hydraulic seal is a relatively soft or a non-metallic ring captured in a groove or fixed in a combination of ring, okay, forming a seal assembly to block or separate fluid in a reciprocating motion application. They are used in critical in providing a way for fluid forward to convert to linear motion. The types of seals. Okay, based on the sealing, there are two types of sealing, that is the positive seals and the non-positive seals. So positive seals means do not allow any leakage, and non-positive seals means permits internal leakages. Okay, so these are the basically two types of seals, and based on the application, static seals and dynamic seals. So static seals means there is no relative motion between the mating components. So where you can going to use the sealing material or the sealing, so that you can call it as a static sealing. Okay, wherever there is no relative motion between the moving components, the component should be in a static condition. In such situation, if you go for using the static that is steel seals, so that kind of seals you can call as a static seal. Dynamic seals means what? There is a relative motion between the mating parts. So best example for this dynamic seal is the piston rings. Okay, so because there is a relative motion between the cylinder and piston inside the cylinder, so that's why, so piston ring you can call it as a dynamic seal. Okay, so the next is based on the shape of the seal, so you can categorize or differentiate the different kinds of sealing material. So that is a O-ring type, cord rings, V packing, U packing, cup packing, composite seals. So then you can go with these different kinds of that is what figures, that is O ring and U cup shape. Okay, that is female. Then again U ring, V ring. Okay, this is a V ring type, and this is a male V ring adapter, and this is a female. Okay, so these are the based on the shape or this size, you can going to distinguish between the different types of seals. Then the positions of the seals with one figure. So I am going to explaining wherever you going to install this sealing component in the hydraulic system or in the hydraulic components. So you can go with these different locations of the location placing of this dynamic and static what sealing, that is the wipers, single acting U seal, okay, wear rings, buffer seal, wear rings, wear drips, okay, double acting piston seal. So next, the factors affecting on the sealing component, that is a sealing device, that is one is the pressure. Depending upon the higher or lower pressure situation, so then temperature, leather below 65 degrees Celsius, plastics up to 260 degrees Celsius. So then operational speeds, that is a compatibility with the oil, metal, clearance, alignment, metal finish, life expected. So based on, you can consider these parameters or the factors while selecting the sealing for the hydraulic system. So then you can go with the sealing material. So sealing material means what, you know that the sealing device or the component, they made up of the different types of material. So in that the major or the mostly which are the material they are going to use to make the sealing materials I am going to discuss here. That is the first one is a leather seal. Okay, this leather seal, that sealing device or the sealing component is made up of leather. So it is having its some properties. Okay, it is a tough, pliable, resistance to abrasion, wear, stress and temperature effect. And second material is the rubber, poor resistance to the petroleum fluids and rapid aging when exposed to oxygen or ozone. Next one is the plastics. Okay, fluoroplastic are the fluoroelastomers, high heat resistance, okay, compatible with the fluids. So next is the metals, high pressure, easily bent, hard in compression. So based on the application, okay, and the parameters which are you consider for the hydraulic system, so similarly in that way you going to select the material for the sealing device or the sealing component with the different materials for the different application. So okay, so next, yes, dear students, so just now we have discussed about the sealing devices. In similar way, one more component which are used in the hydraulic system, that is the filter. So at the section line you are going to use this filter element. So you know that as the word you heard about filter means it is used for to separate the impurities from the hydraulic fluid. Okay, so that is what the filter. Okay, so you are going to classify the filters on different way. So that is what according to the filter method. So how you going to filter the hydraulic fluid? So based on that method you can classify the filter as a mechanical filter and the absorption filter, okay, and absorbent filter. Okay, so that is what based on the method of filtering what you are going to use, whether you go with the mechanical filtering or absorption type or a absorbent type. So what is a mechanical type? Filtration. So in this mechanical filtration contains metal or the cloth screen as a series of metal discs separate by the thin spacer. Mechanical filters are capable of removing the only relatively coarse particle from the filter. Okay, so that is what the mechanical filter. It is nothing but what you can call it as a mesh. So that is a metal mesh what you are going to use to filter the oil or any liquid. So in that way you are going to filter the hydraulic fluid. That type of filtration you can call it as a mechanical filtration. So next is the absorption filtration. So this absorptive filtration is that, so these filters are porous and permeable material such as paper, wood pulps and diatomaceous ether, cloth, cellulose and asbestos. Paper filters are impregnated with the resin to provide, okay, added strength. In this type of filters the particles are actually absorbed as the fluid permeates the material. Hence the filter is used to extremely small particle filtration. Okay, if the very minute component, minute size impurities are there in the hydraulic fluid, that can be separated or you can filter by using this absorption type filter. So next one is the absorbent type. The absorption is the surface phenomenon and refers to the tendency of particles to cling to the surface of the filters. Okay, thus the capability of such filter depends on the amount of surface area available. Okay, absorbent material used including the activated clay and chemically treated papers. Okay, so these are the three basic or the based on the filtration method. Okay, so what type of filtering method you going to adopt? So based on that you are classifying the types of filters are mechanical filters, absorption type filters, absorbent type filters. Okay, so next second type is what? According to the size of the force in the material. Okay, that is the surface filters and the depth filters. Okay, so in the surface filters these are nothing but the simply screen used to clean the oil passing through the force. Okay, that holds what they made of, and the screen thickness is very thin and dirty unwanted particles are collected at the top surface of the screen when oil passes for the strainer. So next, depth filters. These contains a thin thick walled filter medium through which oil is made to flow and the desirable foreign particles are retained. Okay, much finer particles are arrested and the capacity is much higher than the surface filters. Okay, this is a depth filter. and next one is depending on the amount of oil filtered by the filter. So that is the pull flow filters and the proportional flow filters. Okay, these are the two important. So even these, particularly these two only they ask in the examination basically. Okay, so what is this pull flow type filters and the proportional flow type filters? So here you come to this figure. So this is a pull flow type filters and this is a proportional flow type filters. So here pull flow means the name itself is indicating that whatever the fluid it is flowing through the hydraulic system, that complete fluid is going to pass through the filter element. So that's why you can call it as not 100% filtration. But in case of proportional flow means what? Only some percentage of oil you can take out to the filter and you can separate the particles. Again you can mix with the remaining fluid and pass through the hydraulic system. So that's why I can call it an proportional flow. Proportional type filters. Okay, so what will happen if you go with this pull type filters? If the complete oil passing through the filtering element, okay, anyhow you going to separate or you can arrest the all impurities or the foreign particles which are there in the fluid. But at the same time, what will happen? The pressure of the fluid will going to reduce. It will affect on the performance of the systems if you going to filter the complete hydraulic fluid. Okay, so that is what one drawbacks of this pull flow type filtration. So at the same time, if you come to the proportional means, so this is the inlet line. So from here we can take out some 40-50% of the hydraulic fluid that will pass through the filter element. Again that filtered oil it will going to mix with the remaining oil which is non-filtered element and it will go to the hydraulic system. So this is what the proportional filter. Okay, bypass filter you can call it as one more name for this is a bypass. Only some percentage of oil is going to filter. Again that filtered oil is going to mix with the non-filtered oil and go to the hydraulic system. So this is about the based on the amount of oil going to filtered in the hydraulic system, that is pull flow type and proportional flow type. Again next is according to the location of the filter. So this is also a very important question. They may ask the separate question on this. Okay, you can explain the filtration method based on the location of the filters in a hydraulic system. Okay, so because you know that filtration means what? You can place anywhere in the hydraulic system, but the function of this filtration is that you can remove the contaminants from the hydraulic fluid. But at the same time the location is very important, where you going to place the hydraulic this filter element in the hydraulic system. So there are three locations. So first location is at the section line or the section side filter, and then second type is the pressure side filter, and third one is the return line filter. Because I'm just simply explaining here with one circuit here. So this is a piston cylinder. Okay, so actuator it is, and it is having the directional control valve here, and this is a pressure control valve, and this is a tank or the reservoir. This is a filter component, and this is a pump, and in order to run the pump you can connect it with the motor. Okay, these are symbolic representation of the hydraulic circuit. Okay, in later stages you are going to study in detail about this. Okay, how you going to represent this is a symbolic representation of the different components, because while discussing in the basic components of the hydraulic system you can making some rough diagram, because later on stages you can convert those two into symbolic representation. So this is what the this lower section you can just concentrate on the cursor point. So this is a reservoir, you can represent in this way, and immediately above that it is a filter. So after that it is a what pump. Okay, and it is connected with the motor, and this is a pressure control valve. Again excess fluid will go to the again reservoir tank. Again this is a direction control valve, and this is the actuator. Here you are going to convert the hydraulic power into the mechanical power. Okay, so in all three other two also it's the same way, but I am going to concentrating on the location of the filter here. Just see here in the first figure the filter is located in the section line. Okay, see this is the section line, the space between the reservoir tank and the inlet of the pump and the outlet of the reservoir. If you place the filter means you can play it is a section line. Okay, so here if you going to place this filter means this is the first type, it is a what you can call it section line filter. So this is one type, and in the second figure you can just say identify where I am locating the filter here in the pressure line. See, after the pump and inlet of the direction valve. Okay, so I am placing the filter here. So you just concentrate on the just look at the movement of the cursor here. This is a filter, it is located in the pressure line, because here in this line the fluid is at a higher pressure. So in in the third figure you can just see the location of the filter in the return line, so not in the section or not in a pressure. So once that oil will go through the pump or the pressure valve, direction valve and actuator will like convert the hydraulic into mechanical power, again that low pressure fluid will come back to the reservoir. So during that in such cases you can going to place this reservoir. That's why I can call it the return line or the return side filter. Okay, clear? So these are the three different locations of the filters. Based on the locations you are going to classify the filters. So there is some specific this one is there. So because whatever the filter which is located in section line, it will only filter the small size component, that is the small size particles from the hydraulic fluid. Because if you locate only the filters in the section line, it will affect the performance of the complete whole system. So that's why you cannot filter all the oil at one location. Okay, so that's why you're going to place, if you have one hydraulic system, means you not only locate the filters in the section line, you can locate in a section line also, in pressure line also, in return line also. Okay, so that is important. So next thing is offline filters. So that is based on the offline filters, that these filters are used depending from the hydraulic system to clean the hydraulic fluid before it enters the hydraulic system itself. Fluid is full from the reservoir through the filter and is returned to the reservoir. Okay, so intake breath filters, it is offline. Before starting your hydraulic system, you can filter the oil and again you can fill in the reservoir. So that's why I can call it an offline filters. So again at the same time, one more component which are used in the hydraulic system is the hydraulic strainer. Okay, these are very important: strainers, filters and the sealing devices. These three components. Strainer is nothing but, again it is as good as filter only, but this strainers can only located in the section line pipe at the bottom to avoid the mixing of larger size components with the hydraulic system, that is to the hydraulic oil. Okay, so it is placed, strainers are only placed at the section line, not in the pressure line or the return line. At the section pipe you can going to place the strainers. They are nothing but what, the metal mesh, so that can attach with the section line or the section pipe, then automatically it will avoid the that is contamination of larger size contaminants to the hydraulic fluid. Okay, so this is about the filters. So remaining things we will going to discuss in the next